Hello, my name is Katariina Halonen and I'm a second year game production student from JAMK University of Applied Sciences, and today I'm going to talk about Netcode. So, what is Netcode? To put it short, Netcode is a code library built for networking purposes. And basically, you need Netcode if you want to play with a friend or multiple people online. And you need some kind of solution that keeps all computers in sync so that everybody can see the same state of the game, which is basically called the game state. And this game state includes things like the location of all the players, NPCs, bullets or spells, and stats like scores or money or health. And what makes all of this interesting is that players can affect to that game state by making inputs that can trigger game events, such as movement, collisions, and hit checks. And all of this needs to be synchronized between all computers, otherwise it would lead to a really confusing or unfair gameplay. And what makes Netcode complicated? And the simple answer is latency. And latency in networking is the time it takes for a signal to go from its source to its destination. No signal can travel faster than the speed of light, no matter how good our technology gets. So we will always have to deal with latency. And latency is represented in milliseconds, and it's often referred as ping. And a big portion of Netcode exists simply to take care of this, and different Netcode solutions deal with it in different ways. And here is an example of how our location affects the latency. And this is from my Valorant account, and as you can see, since I'm located in Finland and the closest server is in Stockholm, it will automatically pick that one for me to make sure I have the best possible ping. And one might think that something like 100 milliseconds would not make a difference, but as you can see from the picture, these servers are marked with red color, and I would agree with these color guidelines that around 10 to 50 or 60 ping is good. 70 to 100 starts to feel a bit awkward, which is often called lagging, and anything over 100 is pretty much unplayable. And the latency can never be zero, but for computers on the same wired local network, it can be even 1 millisecond or under. Before I can explain how Netcode works, first you need to understand how clients connect to each other. So first we have the peer-to-peer connection, which is a network structure that connects each player to every other player. And one of the key features is that there are no dedicated servers to run, because clients make direct connections to each other. And this usually, but not always, results to low ping. And on the other hand, it can cause major security issues, and it can only handle a limited number of players at once. And nonetheless, it is actually more common than you might think. And then we have the server client with authoritative dedicated game server. And when using a server client solution, all clients, instead of connecting to each other, connect to a single game server. And the dedicated game server accepts input updates from the connected clients and sends out the resulting game state to each of the clients in its network. And the benefits of using a DGS is its authoritative game state, which allows lag compensation and anti-cheat mechanisms to be implemented. And on the other hand, the server needs to be hosted somewhere, and this has obviously a cost associated with it. And then we have the server client with authoritative client host, and this is also known as a listen server. And this would be a mixture of the previous two. And instead of having a dedicated server, one of the client's machines will act as a server for other clients to connect to. And there are similar benefits to this as having a DGS without the additional cost. But obviously its disadvantage is that the server will only be available when the host decides so. And also, the listen server grants the host player a large latency advantage over the other players. And since the hosting client has access to all of the world's information, it makes it easier to cheat for that player. Okay, and then we can go to the different netcode solutions. And I hope you're all still with me and listening, because this is the most important part, where I'm actually going to explain how these different netcode solutions deal with latency issues. And like I explained earlier, if we didn't have these solutions to deal with lag, many online multiplayer games would be unplayable. So we have the lockstep, which is delay-based netcode, and the rollback. And the lockstep is pretty self-explanatory. And basically, every client processes the same game step at the same time, and they are locked to that step until it's time for everyone to process the next step. And in reality, these steps are really short, and for slow-paced games like card games or board games, this is usually the best way to handle networking. So how does the lockstep handle latency? And the answer is, it does nothing. It literally just waits until all the data has gone where it needs to go, and then it continues. So there is always going to be some delay. And then about the rollback, which it's like a time machine that tries to predict what game state it should display. And once the actual input arrives, it will correct the game state depending on the input it receives. And this happens so fast that it's usually unnoticeable, but sometimes if there are latency issues, it might cause glitching. Like for example, in a fighting game, your opponent might appear to be walking towards you, but all of a sudden it teleports mid-air. But for the local player, the input gets displayed immediately, so it feels really responsive. But if the rollback is so good, why not always use it? Because it is complex. It is harder to implement, and it requires more resources. It's extremely good for certain type of scenarios, such as fighter games, MOBA or RTS games, or anything that has limited number of players and is fast-paced. But for a turn-based card game, definitely no. It would be way too much. And also for some larger scale FPS games, such as Fortnite or PUBG, the network load would be too much. And if all of this sounds too easy for you, there is also an option to combine both of these to minimize the effect of input lag and glitchiness. And finally, you might be thinking what netcode solution I should use. And the answer is there is not a single one-size-fits-all solution for all kinds of games. So you, as the developer, have to evaluate the options and decide what netcode suits the best for your needs. And obviously, there is so much more to netcode than this, but this was just a quick introduction. And if there's something I want everyone to get out of this, is that there are different ways to implement networking properties to a project.